Okay, let's look at this comparison test. And for the comparison test, we're often going to use what's called the p-test over here. Remember that if the sum of the series of 1 over n to the power of p converges, if p is greater than 1, and it's divergent if p is equal to or less than 1. So something like 1 over n squared will always, the sum of, as n tends to equals 1 to infinity, this is convergent. If this was cubed, this is convergent. If it's 2n to the power of 4, it's convergent. All of these are convergent because p is greater than 0. If we have something like the sum of, as n equals 1 to infinity, of 1 over p, that is divergent. If p is less than or equal to 1, it's divergent. Spelled really well by a maths teacher there. Okay, so what we are looking for is a comparison test, and we tend to use this p-test somewhere in our thinking often with these questions. So not always, but somewhere in there we turn it into, we compare it to one of these, something we know. This first one's a nice, easy, or hopefully a nice, easy one. Let's look at a value for n just to get an idea of what we're doing here. Let's say n is 3. So if n is 3, we are going to get 2 over 27 plus 4, which is 2 over 31. Now, I know for a fact that 2 over 27, if I don't worry about this 4, I know for a fact that this, let's get that wrong, is actually smaller than that. 2 over 31 is larger. Sorry. I know for a fact, that 2 over 27 is larger than 2 over 31. This is the larger thing. So, and that's the concept that I'm going to use, that, 2 over 20 is larger than 2 over 30. So I know that if I give this if I look at this, 2 over n cubed plus 4, I know that that is less than the sum of n equals 1 to infinity of 2 over n cubed. Okay? Because every single term of this is less than every single term of that. Now, this is really just two lots of n equals 1 to infinity of 1 over n cubed. This is convergent. So this we know is convergent. This we know is convergent. How do we know it? The p-test, via the p-test. And if this is convergent and this is smaller than it, it must be convergent as well. Therefore, original series is convergent. So as I said, that was a nice, fairly simple one, I guess, to start with. This is fairly similar. The sum of n equals 1 to infinity of n squared over n, square root of n over n squared plus n. We're going to use exactly the same thing. Again, just so I can get it right. We know that 1 over 11 is less than 1 over 10. Or if we let n equal 10, if n equal 10, what we would have on this side is the square root of 10, let's call it a constant because I don't know the square root of 10, over 110, 10 squared plus 10. We know that is smaller than k over 100. So again, that is going to be our comparison. We know that this is going to be less than the sum of n equals 1 to infinity of the square root of n over n squared. Okay, so let's see if this is convergent. So we've got the sum of, as n equals 1 to infinity, of n to the power of a half divided by n squared, which equals, divided by minus n squared times, having a shocker. If I take it up to the top times, what you end up with is n to the power of minus 1.5. This was a really long way of doing it, perhaps. N equals 1 to infinity of 1 over n to the power of 1.5. There's probably lots of other ways you could have done that a lot quicker. And again, because the p-test, since 1.5 is greater than 1, therefore, using the p-test, this series is convergent. This is convergent, therefore any series less than it, and that's what we're really saying, therefore any series less than it must be convergent. And that's really what we are saying. We've looked at a series and we've said, one thing we know for sure is that this series is greater than this series. This is convergent, therefore this must be convergent because it's less than it. Let's have a look at one more question from this and a slightly different one. We've got a minus on the bottom here, so this is a bit different. And it's not so obvious whether this one's going to converge or be divergent. So the first thing we're going to compare it to here is, and again, let's use numbers. Let's use 10 again because that's nice and easy. If we've got 10 over 100 minus cos squared 10, well, I know this is going to be a negative number because it's cos 10 squared. So I know this is going to be negative. So what we're going to get at best case scenario is 10 over 99. And if we just compare it to 10 over 10 squared, just 10 over 100, I actually know now that this is bigger, okay, because we've got a smaller number on the bottom, so this is bigger. So in this case, the comparison is going to be a bit different. N equals 1 to infinity. And I always look at the bottom. It seems to be that the bottom is the easy one to look at. N over n squared minus cos squared n. I know this is always greater than n over n squared. And what does this equal? This equals the sum of 1 over n. And I know this is divergent, which is exactly what we want, because if this was convergent and this was always bigger than it, it wouldn't really tell us anything. Okay, this is convergent and this is bigger than it, so it could be divergent. But because this is divergent and this is bigger than it, it must be convergent. Therefore, since the sum of n equals 1 to infinity of n over n squared minus cos squared n is larger than a divergent series, it must be divergent. That's probably a better way of saying it. Okay? Since this is larger than a divergent series, it must be divergent as well. Okay? And that's the comparison test. They were very simple examples, but at least it gives you an idea. Okay, thanks.